Today we're going to look at a vector addition problem. So let's say we have two vectors, vector A, which is 4 meters in length and 60 degrees above the x-axis, and vector B, which is 3 meters in length and 20 degrees below the x-axis. If we add these two vectors together, we want to figure out what some vector C is that added to those, it sums up to 0. So A plus B plus C will be 0. So let's rearrange the equation to solve for C. So vector C is going to be equal to negative A plus B. And we're going to break this into its corresponding components. It has an x component and a y component. So the x component is going to be the negative of the I hat sub A, so that's A's x component, plus I hat, let me write that in a way that I can actually tell that it's an I hat sub B, that's B's x component. And then the same for the y components, we use the variable j. J hat for A is the y component for A, plus j hat sub B is the y component for B. So let's look at the first vector. I've got vector A here, and it's 4 meters in length. And I'm going to create a right triangle around it to figure out what its corresponding components are. And if this is the 60-degree angle that they've given me, because it makes a right angle with the axis, this is 30 degrees inside. And the inside angle is what I care about. This side is my I hat component. This is I hat sub A. And then this is j hat sub A, my y component, my x component. And I'm going to use trigonometry to figure out what those are. So the cosine is the adjacent times the hypotenuse. So my j hat sub A is going to be equal to the 4 meters times the cosine of the inner angle, that 30 degrees. And my I hat component for this triangle, this specific vector, is the opposite side. So it's going to be equal to 4 meters times the opposite is the sine of that 30 degrees. And those are my two corresponding components for my first vector. Now let's look at my second vector, vector B. If I were to make a right triangle for vector B, this is the 3 meters. Because vector B is below the x-axis, this j hat component of vector B is negative. This is the I hat component of vector B, which is still positive, it's in positive x direction, but this y value is going to be negative. And I can account for that in a few different ways, but to make the math simple, because of the direction that the degree is going, if I were to think of it like as if it were going around a unit circle, going around a unit circle, positive is the counterclockwise direction, but because this would be going clockwise, it's negative. So instead of writing 20, I'm going to write negative 20 degrees, and that'll take care of all the signs as in terms of the components. So the same thing, the j hat component of vector B, in this case the j hat is now the opposite side of the angle, so it's 3 meters times the sine of negative 20, and the I hat component of vector B is now the adjacent side, so it's 3 meters times the cosine of negative 20. And all I do now is just add them together. So Cx becomes negative 4 meters sine 30 plus 3 meters cosine negative 20. Cy becomes negative 4 meters cosine 30 plus 3 meters sine negative 20. If I add those together, I can put it back into the vector notation to solve for C. I can just write my answer like this. C is equal to, if I were to add these two components together, right? So the x component is the I hat component, and the j hat, the y component is the j hat component. Adding these together and just making sure when you put them in your calculator, you're putting it into, you have it in the degree mode, not the radian mode. It becomes negative 4.82 minus 2.44. And this